example. So, as if we consider this X with the usual metric, and we define a map T from X to X by this rule, Tx equals to X plus 1 X for all X in X. So, verify that it is a basically contractive map, not contraction. So, maybe just please try. Maybe of course a lot of people know about this example. So maybe we can try. So what is the question? T is but it is basically contractive map. Okay. Contraction, but it is a contractive or strict contraction. So that it means that we cannot find out you can say Lipschitz constant which is strictly less than 1. This is the meaning. So maybe just maybe let us try this problem. So, so it has two parts. One is the first of all show that it is a basically contractive map, and another is it's not a basically contraction. It means that you cannot find out a basically alpha, or maybe you can say Lipschitz constant which is strictly less than 1. And of course, this is a one of the well-known example. Uh, Generally, all people in point theory they refer this example. So maybe just take maybe few minutes. So okay, you can cover also now audience as well. Now you have a solution of this problem, because this is a very well known example from the metric fixed point theory. Is it okay? So let us come to the little bit nice spaces, okay? Because generally things on the real line is always little bit easier than the space of the function spaces. So just I am interested in this example. It's the same thing, because big people, of course, a book from the and Kirk. So this is the, if I consider this and now M to M. Of course, this is also basically complete, because it's a closed subset of C of AB. So no problem at all. So this is basically complete. F operating on T is equals to just T times T for 1. So basically, and this is expected code or by the closed subset with respect to the same metric. So this is a space of X. Why this is also complete. T is a basically map from complete metric space to complete metric space defined by this. So again we have a basically same exercise, show that basically contraction, but it is a basically contractive map. So this is the difference. Of course, problem is same, but this is generally to throw every time. But when you basically read the book from the means big mathematicians or like that, you have generally examples on this type of this function spaces, or maybe you can examples on the disk, or maybe in algebraic topology. So just so maybe let us try for this part as well. So question is that uh, is not contraction, but it is contracted. And my space is complete, so that's why this does not have a fixed point again. Of course, this does not have also a fixed point, because this is a basically my complete metric space, not compact. Of course, if it is a basically contraction, then by Banach fixed point theorem, it has a fixed point. But this is not basically a contraction, this is a contractive. So as yesterday I said, for the contractive is so much smaller. So this is not a basically compact set. So if we have a basically a fixed point, so just Tx equals to x, so x equals to x plus 1 upon x, and of course 0 equals to 1 upon x, which is not possible. Which is not possible. But we have to do same thing for the basically this interesting exam from the C of AB. So maybe first of all we should check whether this is a closed subspace of this or not. So this is a simple exercise. So please do it. Whether this is a closed subspace of C. Once it is a closed, of course it is a complete. Maximum of supremum, because it's basically on closed and bounded, so that's why no problem with the supremum. The legal metric C of it need not be complete. So first of all, check whether this is a closed subspace. If it is a closed, then of course it is basically complete, because every closed subspace or subset of a complete meeting space is complete. So in the second example, we have to do steps. So that's why generally these people, can say Hamsi and other Jemski or Kirsty, they do all the things in generally function. So please prove. So did you prove this is a closed space of C of AB? Just few lines. Just use the sequential or maybe some other. So value will be at also that sequence is 1. So that's why this belongs to the basically just is space. So now next is a basically closed circuit, also complete with. So now map it is a basically contractive but not contractive. Contractive and contraction. Because if it is a contraction, then it has a fixed point because M is complete. That's why in the theorem of complete space. So I think this will take a little bit of time, or can discuss more problems. So now Imdas sir is here. Now he will tell you something about, of course, not fixed point theory, or maybe a little bit outside the basically fixed, uh, you know, yes, for maybe total. No, no, overall. Now 5 years is retirement also, so that is you are still so maybe for more than 40 years. Just so he will share the basically some his experience, and of course not for research, for teaching as well, point of view as well, and some important things about the basically fixed point theory. So I invite Indra sir just to share few ideas regarding this topic. Yes.
In fact, you can say that this is an arrangement as opposed to the engagements of professors. I was not prepared. I was asked in my early days, my seniors, my teachers, that you should not go to the class without preparation. Or if you go to the class without preparation, it is something very similar to a crime, committing crime. So I am here before you with any preparation. Because I was told in the morning that you have to engage, I have to talk to you. So I have come to have a conversation. Maybe I cannot very technical. And at that very stage when you are away from mathematics, as you know, its name is mathematics. But its better name you can say रियाजी. इसको कहा जाता है रियाजी. जैसे if you look at this department, it is termed as शोबे रियाजी. It means mush, practice. If you don't practice mathematics, you will be definitely not that good, not that confident as you see, because you have to be always in touch, in practice, in mush. उर्दू में लफ्ज आता है मश्क. और रियाजी means रियाज करना. जैसे anybody used to, this is a riyaz. And as I am not doing anything, I am away from mathematics for the last 4 or 5 years. So obviously, and at the same time, to come and my experience. So I have come to share my experience, what way I come through as far as the academic life is concerned, because some of you are beginning the academic life, and obviously I see very senior persons also in the audience. So what will I say? That will not be for the seniors, because they are already learned a lot of mathematics, but it is for my young students who are here. I will have some of my experiences during the years of my teaching here. I will ask you, I will invite your attention if I ask cross topology the first time in life. Starting your studies to here, when you come across topology first time, what is your reaction? टोपोलॉजी से आपकी पहली मुलाकात कब हुई, क्या जवाब देंगे? दिस इज अ वेरी सिंपल क्वेश्चन. तो क्या कहेंगे आप? जो भी हो आप फ्रैंक बोलिए. देखिए मैं तो है हमसी साहब को आपने देखा, ही इज अ वंडरफुल स्पीकर. आई हैव नॉट सीन मेनी स्पीकर्स लाइक यू, मे बी 1 or 2. We all are teachers. We must know our limitations. A person must know his weakness first. The strong points are always your strong points. Don't focus on your strong points. Always focus on weak points. What is your weak point? And try to consolidate your weak point as a strong point. Try to transform it to your strong point. This I will share my teaching experience, what way I will go through this, and what experiences I have. So this is one of the experiences I am asking you, that how will you say when you come across topology first time? SC, or you are in MSc final, or somewhere you are teaching mathematics. If I ask you topology, when you come across topology first time, what is your answer? Some of you? There are two kinds of teachers. These days our teachers are not allowed to fish out the things from the students. Like Professor Khamsi is very good. He is trying to fish out the things from you. And this ensures that you are in, that not as if you are away. So you have to keep the students involved so that he may not be out of the classroom. Like here in algebra, some time back, he passed away, just passed away. His beauty of his teaching was that he cannot allow you to be away. So he will as well ask you a way of teaching is what? Try to from the students themselves. And that is the best way to teach the students. You as a teacher, what feeling you have? To this very question, when you come across topology first time, as a teacher, when you realize? और कुछ? Yes. You are very near to the correct answer, but it's still not 100%. It's not the 100% answer, but he is quite near to it. Yeah. Mm-hmm. Yes, counting numbers. It is very difficult to, when you become a teacher and you started teaching students, then you must have this feeling that what is the topology, how it came out, to realize it, or when I have to say it, that here is the topology. Whenever you say something is open, whenever you say the open interval AB or open interval 0, 1, there is a topology. And when you say that, you cannot say. Realizing the difference, you say here is the open without carrying it. Because real line is open interval may not be open because you may have the topology. Because you have also many. What will you say? There is also a topology. That very topology is fixed. So what you say in all earlier mathematics, starting now from the school, we have the topology. The best thing is to realize that talk of anything open. So forth. The topology, what I want to make a point, what I realized during my teaching, this I have not read anywhere. This is, I am saying, is in mathematics, topology is everywhere. You cannot say that here is no topology. You are teaching, so have the topology. Because what the topology fixed, that is what you topology, open interval topology, as you have, which you can metric topology, as you have later realized, introduced metric spaces topology. The topology is there in calculus also. Topology, that is a natural. Go next. You have the metric spaces, and then you define the topological spaces. There is a considerable improvement that here is logical spaces. What you do, that every metric space is a topological space, but every topological space need not be a metric. As you have read in the MSc, if you look at this, can answer this question. So what you say, every metric space is topology, the topology is standard, that is open ball topology. So whenever you say, what we can say, every metric space is a topology. Varying. So in topological space, whenever you study the topology is varying. You write xt is a topology, means this t is varying. If you take a metric space, a topological space, its topology is fixed. It's not varying. And whenever you say enormous space, look at every inner product is a topological space. That too, the for openness, closeness, compactness, these properties, such properties. So obviously we gain because your object class of, so you have the class of, now you have the class of spaces, and it's far, and you see. You start from a metric space, is still losing. Topology have in the topological setting. Why? That what we look relatively smaller class spaces, so to the class of topological. Since most of you have learned a lot of mathematics, then you have always the uniformizable topological spaces, or a topology or a topological space where you have metrization. Metrization means what? That you have a topological space, you have a metric on this, your metric topology, and then you have another. Sorry, topology. Is a topology. Space. Here, as I see this very department, UGC. But if you try to correlate this, distinguish between anything like uniform continuity or uniform convergence and uniform continuity. But if you go beyond, this is not available. Like in topological space, convergence. It is open and contain that very point. This is one. Most standard book is Kelly. These days there are many books. If you look, my personal point of view, Munker's book have been, when you, three-dimensional geometry by the book of G.R.T. Bell, analysis in BSc by T.M. Foster's book. No Indian book was used over here. These days we are not that very cautious, but we should be cautious. Because those books which are standard books, they are error-free. Maybe our books are also good, but there are chances that there are fundamental mistakes in our books. That is the reason why we use books from the standard authors, and there are certain books which are free from the boundary. They are used globally. Like look at the major theory. Many standard books, they are all from foreign authors. Maybe one or two books have by authors, but you have to be careful by using those books, because there are subjects where many good books written by our authors are not available. That is what is there. So what I realized during the course, while going through this, that it is very dangerous to change the book in the course you are preparing. One thing is what here, that what are the syllabi that we should be very careful these days, that what should be our syllabi. And there can be no better entity, better person to choose the syllabi is teacher themselves, because teachers know what to do and how to do and from where to do. Because mathematics is a subject where you must have the background, means जिसको मैं हिंदुस्तानी ज़बान में कहूँ तो पिछला सबक याद होना चाहिए. अगले सबक के लिए आप लोग समझ रहे हैं, अगले पार्ट के लिए पिछला पार्ट याद होना चाहिए. ऐसा नहीं पिछला पार्ट याद नहीं, आप चले आए, आप टीचर से उम्मीद कर नहीं करते. ऐसा होता है आजकल कि वो पिछला कुछ भी याद नहीं है, आप टीचर बेचारे को ब्लेम कर रहे हैं, कुछ भी नहीं पढ़ा रहा है, कुछ भी समझ में आ रहा है, कुछ है. हमारे यहाँ पे डिपार्टमेंट में हमारे सबसे फेमस टीचर थे, उनके बारे में लोग कहते थे, जो सबसे ज़्यादा मेहनत से पढ़ाते थे, कि भाई कुछ समझ में नहीं आ रहा. तो ये फेयर नहीं हो टीचर के लिए. So you have to go to the level of the student. That is the best thing, as you have to say. Every teacher has a different way of doing it. As I mentioned about our teacher, he has his own way. I have seen in the class, he used to come, he started displaying with something, and thereafter you say, no, it is not happening well. I will come tomorrow with further clarity. I have said many times to him during his younger days. But definitely, if you look at his competence, that was unquestionable. So we have to be very involved in our subject as good as possible, as I have said. The point is turning away, what you say, that topology cannot get you uniform continuity and uniform convergence. Why? Because it has the size of it requires the size of the neighborhood. Then the question is that can we retain this somehow beyond metric spaces? Answer is yes. And what is answer is offered by another notion defined by Andrew Weil, that is uniform in spaces. Some of you have heard uniform spaces. Uniform spaces can retain uniform convergence. Still there are many classes, many topological spaces which are not uniformizable, and still there is on the journey as a teacher. You see, with many courses you teach. Like another experience I had. How much time I'm taking? 10 minutes. This is the hard part of mathematics. That is what during my teaching I enjoyed most teaching living. That's the most challenging and difficult course, and this part is also difficult. But if you look at the ideas are simple. So before you start undertaking or teaching anything, you have to always be very careful that what is the underlying idea. Like if I define the measure, some other things. But let me go back. As I said, I will talk something about fixed point theory also. Sometimes working with mathematics, you can get some very simple and very important. I would like to draw your kind attention to the paper of Victor Barriant. Victor Barriant has proved in 1968, which is the part of your syllabi in all the books. That is what, if the iterate of a map on a complete metric space is a contraction, still you have the fixed point and you still have the unique fixed point. Look at this very result. This has come in 1968. This is not a very old result. This has come in 1968. Or if you look at any syllabi or any book, this is referred. Even I have seen in the Jain Sahib book, another standard book, in Karajik's book, everywhere this reference is there and it is included and it is taught. But look at how he got the idea that iterate of a map is contraction, map may not be contraction, still you can have the fixed point and still you can have the unique fixed point. And this very result you can use in many ways. I have sometimes used it also. Just look at, yesterday we were talking about the Dirichlet function. Professor Khamsi was talking about the Dirichlet function, and we all know, as far as my experience is concerned, only Khamsi can define Dirichlet function. Everybody can, only Dirichlet can define Dirichlet function. I am trying to say that only Dirichlet can define the Dirichlet function. Just look at this magic. As you have seen, the wonderful thing what I come across during the teaching, the excitement, that Dirichlet function is a everywhere discontinuous function. Have you given thought to it? Some of you can help me to prove this very fact, that Dirichlet function is everywhere discontinuous. Idea, underlying idea. But here is a function which is not continuous at single point, everywhere discontinuous. And the idea of the proof is very simple. Some of you remember? What is the idea? Sequential. Definitely, you will require some way. As he said, is what the simple fact was, what if we can find a sequence of rational converging to every rational and vice versa. We can find a sequence of rational converging to irrational, also rational. That is the case. You know that, as you said, the very theorem you used is what xn converges to x implies txn converges to tx. What is here, which you can make this very point, that this very function, Dirichlet function, is not a contraction, and you can very easily realize this. Are you agreeing with me that Dirichlet function is not a continuous function? Is not a contraction. Contraction, as you see, contraction, you all I think are familiar with the definition. Here dx txy there are two facts here. Look at this very ratio, this will give everything, then this really ratio. So always having the meaningful things. And look at this ratio. This ratio may be more than 1, less than 1. X is not equal to y, sorry. X is not equal to y. So this very ratio you consider, and this gives everything. Like if it lies between 0 and 1, strict, then it is a contraction. And if it is strictly decreasing, you have the idea of the contractive map, as was discussed yesterday. This is a larger class. Okay. And then if you take k greater than 0, this is we call greater than 1, this we call as expansion. There also exists a literature on this also, that d of t x t y this you call as contract. What the point I am trying to make is what, that simple idea, this very fact is simple. I advise you, if you are having sincerity, then as a teacher you can even do such kinds of things. You can come across such kinds of things, they are of vital importance. This very fact, which was proved in 1968, very simple result, very simple proof. Because if t is a contraction, then t to the power n is a contraction, and to the power n, if t to the power converse is otherwise. This very theorem takes care of the converse. T to the power k is a contraction, then still t has a unique fixed point, where on a complete metric space. So otherwise the idea is different. Like this very theorem, what I said, Dirichlet function cannot be covered by Banach contraction principle, but Dirichlet function can be covered by this very simple result. This result has come in American Mathematical Monthly 1968, that if t to the power n is a contraction, here I have taken t square, but t to the power n is a contraction, then still t has a unique fixed point on a complete metric space. And this idea I have used in many ways. Or you can also use this idea, like if you take t square, this you can replace by t1 t2, and you still have two classes, and then you have class of functions. So this very idea you can use here, like t square, now you can replace this t1 t2, and then of course still you have two classes like t to the power p, t to the power q, and you can work with this class of mappings, and you still having the commutative definition, you can always find the fixed point. And the root of this function lies, those who are familiar with the literature, this goes back, trace back to Junk's fixed point theorem. From there you take a pair of map. This result has come in 1976, that Banach theorem or Banach contraction principle, this can be extended to a pair of mappings. So you look at how trivially this goes on. This is not very difficult. How we are writing our theses these days for our doctoral award, very simple. You class this, generalize, and you can go on doing this thing. And look at here, if you look at classically, sometime you realize that this is not that significant. Thereafter, when people used to pursue it, it looks more significant, as if it is very novel. So his theorem is what, just look at the matter of the fact is what here, commutative is a condition, but this is not that business. But this very result, what I have said here, if t to the power n is a contraction, this is used in our MSc classes also. Then on the complete metric space, this contraction, this very idea is used in our MSc class also, like our Picard's theorem, that is also extended to this class, and that you can see for this even in your Krajic's books. So this very theorem, like Picard's theorem, you all teach, I think so. So Picard theorem, you teach differential equations for this existence of uniqueness, so uniqueness solution, existence and uniqueness of the fixed point of the solution. But if you look at the strongest point of the Banach contraction principle is what? That you can take a point x, you can create a iterate, its limit is fixed point. So there can be no simpler than this. If contractivity and completeness are there, you take any point x naught, create a iterate, find the limit, you will get the fixed point. That is the most simple. So this is why this theorem was proved. This theorem was so significant, and it can be used anywhere. Like I have said, the differential equations, Picard's theorem of the differential equation, you have a suitable condition. This very theorem enables you to what? Now you can take this for the power, any power of the map, and any power of the map, this class definitely covers a larger class. So the point I am trying to make here is that even simpler results sometimes, which you think they are not that significant, they go a long way. And they have the citations of the order of any order, like you look at this one here. One thing is related to my research life when I was working here with Professor M.S. Khan. There I got a paper from Salvatore Sessa. He was very weak in English. He has sent me a paper where he has considered a very simple condition at that very juncture. I never realized it was that significant. The definition was, he was trying to enlarge the class of a commutative class, because it is there in Young's theorem. And he has considered a very simple contractivity condition. He just used contractivity condition. And what he did is, what look at the class. Suppose I take pair of map T S x, and this is obviously could be what here the possible gradient is what, there are T x, T y, and so on and so forth. Initially what he considered this. So, this could be equal to or greater than 0, because this is a often non-negative real number, this is also a non-negative real number. You have the comparison, what are the possibility. Salvatore did this class. Sorry, this is equal to this very class. No, sorry, still I am not correct. This is d of S x T y. Yes, S y, yes. S x T y, T x S y. Look at this, could be greater than 0, this should be equal also, because two non-negative real numbers are comparable. And he sent me this paper to Professor Said M.S. Khan, with whom I was working. He gave me as a research scholar that you go through these books. I have read this paper and I have said this is a very good idea. He says, as I can say here, I can recall, तुम तो हर बात को अच्छा कहते रहते हो, ये कह के उन्होंने टाल दिया. What I did is, what this was, Italians are often not having good English. So, I have written with pencil this paper and corrected it in English. Its title was a junk type theorem, and I replaced it, the original title what is there, a weak commutativity condition in fixed point consideration. This is right I suggested, and I write everything, and the pencil line send it back, because that time you do not have the mail by post. So, I posted this very mail to him, and he published this paper in publication American Math Institute, Publication Institute, Belgrade. And I do not know, you can just verify, it has more than 1000 citations. Can you realize that very juncture, way back in this I am talking 1982, maybe it has published in 1982. So, what I wish to say by this very instance, that you people may not feel that you cannot do good, still you can do good, and very simple, and often very simple and natural things are good, and they are later taken by, like you write a paper, or many of us are used to write a paper, some might be a paper you do not expect that this will be that good, and later it turns out to be very good. Why? Because it is pursued by many, because it attracts the considerable, and after this there is a history, I do not want to go into that, because that is very technical, that any common fixed point theorem is bound to have, common fixed point theorem means two maps involved, and there exists a point x such that there is a two points remain fixed under S and T. So, that is the case you have, but that is not very significant. Obviously, the original theorems are what just involving one map, but that is true, is a way of literature. What I am saying, that never feel discouraged, never feel in disgust, always carry on the journey, and of course, with composed and considerate and focused manner. What is very important is focused. In mathematics, you are always required to be focused, and try to teach. Another thing which I wish to say, try to teach as many courses as you can. This is one thing I would like to say, because this is not very often taken by the candidates, by the youngsters. What you see, that if you teach many courses, you have the idea from the other, your vision is broad, Like if you are on the first floor, you see some part of your locality. If you are the fourth floor, you look at better about your locality, and when you go higher, you have more wide open vision. So, as long as you read many courses, they give you the idea for the other course, and you get stronger, because as you know that many coaches in the games, I have read many where they adopt that means. I have read about a volleyball team, what they did while they were practicing, they were added with some weight. So, they have some weight while practicing. When there is a match, those loads were removed, and they are feeling lighter and doing better. So, if you apply yourself through this process, as I have said, what I am able to say this, because I have taught many courses. Like measure theory, I have taught measure theory. Measure theory is very difficult to teach, because it involves many things. It is not so simple, because but idea is very simple. Can you, some of you can share what is the idea of a measure? कुछ भी जो भी है, whatever you feel. Huh? Length means what? Length, no. Length is generalization of a length is your metric. That is metric, how metric you define. No, it is the idea is what, that if you have an interval, you have a length. Look at, if you go through this, better motivation you have in the Rana's book, because generally the standard books, they never care about this. If you go through this, you find the most easily read book is by S.K. Barbarian. That is very simple to read. We can go straight away and read S.K. Barbarian, because you do not need to much, but it has other ideas. As I have said in the beginning, that you cannot frequently change the book. You book from one book to another, it is not so simple to pass through. Like Halmos book and Barbarian book is somewhat compatible, because they use the same idea, like sigma ring and ring, or sometimes semi algebra. But look at the Roydon's book, it used to always use sigma ring and sigma algebra. So, their facts are, their class of subsets are definitely different, and they cannot pass from one book to the other. As I have said, that most readable book is S.K. Barbarian, and the best book you have is still, I feel, is the H.L. Roydon's book. But the idea is what, just you have the length of an interval, as you have in the case. What about the other sets in the real line first, and later what was the idea of the measure is what, can we associate a length to every set and to a general set, because you go thereafter to a general set. And salient properties are what door on the real line or the real interval, because you look at, he has considered the intervals, Rana's book, before starting anything, he has collected the intervals and look at these properties like pairwise disjoint, and how about the solidity property and other things. So, what is the thing over there, what background do you require? And I have read somewhere that Henry Lebesgue is considered as one of the most solid mathematicians. Some people used to keep him in the class of Newton, Einstein. Why? Because you cannot have another example of a generalization which is so significant. Look at the Riemann integration, at the generalization of the Riemann integration to the extent of Henry Lebesgue. Just look at here, and so significant that is a part of our syllabi. What Henry Lebesgue did actually, that he extended that, look at, we are talking about the Dirichlet function. He was able to integrate a Dirichlet function. Like Dirichlet function is measurable. Look at such a typical function is still measurable. And what is there? The commitment, devotion, and the way we used to have our training. Like these days, our individuals, our youngsters having relatively poor background, they are not able to have education properly. But actually, they have the motivation. Like Henry Lebesgue was also coming from a very poor family, and he was taught by his fellow men, by his neighbors, by his town people. He was not having enough support. This I have read somewhere. He was educated with the help of his town fellow, all his inhabitants of that very town, who helped the education of Henry Lebesgue. But look at the impact he has made. or if you look at the Lebesgue integration or its overall impact on the mathematics. If you go beyond sophisticated mathematics, now there are participants. Dhage Saab, where is Professor Dhage? No, he 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 used to write sometime even papers on differential equation involving Lebesgue integration. Like most of the time of the differential equation we are using, they involve what? They involve Riemann integration, but there exists a literature, there is a subject which uses Lebesgue integration as far as the differential equation is concerned. So also research in those directions also used to function, used to progress, and measure theory itself is the research domain. You can just look at, and all the basic things you just look at, and if you go beyond to everything, one cannot avoid as a teacher real analysis. Can you avoid real analysis? Obviously no, because real analysis can be a background to all mathematics, even calculus, the very first course. If you are not confident, if you are not well versed with real analysis, you cannot teach even calculus confidently or honestly. So overall, the point I was making is what you all, most of are young, you don't avoid to teach the course. As soon as you find a chance, you grab it. Maybe you are having time, hard time, but still you will be a different person, you will be an improved person. That is what the point I wish to make by dint of my experience, not anything else, that if I have something this, because I have taught many courses, almost algebra, I was very fond of algebra, I used to teach algebra also. With the linear algebra, I cannot say what I have not taught. I have taught most of the courses, and this helps me because I can appreciate anything you are talking. I can appreciate, maybe successfully or unsuccessfully, but I can appreciate. So क्या मुझे बैठना था, तो मैं एक शेर पढ़ देता हूँ, बहुत आसान है। मिटा दो अपनी हस्ती को, मिटा दो अपनी हस्ती को, अगर कुछ मर्तबा चाहो, ये दाना खाक में मिलकर गुले गुलजार होता है. मतलब समझ गया? Okay, okay. The translation is very simple. When we used to crop our crops in the field, always see what will happen to the seeds. This is the idea. Seed का क्या होता है? Seed तो उसकी तो हैसियत खत्म हो जाती है ना, जो बीज होता है वो तो बेचारा खत्म हो जाता है, मगर उसके बाद सब्जा उगता है, उसके बाद फसल लहलहाती है, तो बीज का वजूद खत्म हो जाता है और उसके बाद फसल उगती है. तो ऐसे ही कोई काम इतनी आसानी से नहीं होता है. जैसे मैंने कल शेर पढ़ा था आपको उसके लिए कि मेहनत करनी पड़ेगी, कुछ भी करेंगे तो आपकी फसल ज़रूर लहलाएगी. और मैं तो ऐसा मानता हूं कि अगर एक बहुत मेहनती आदमी है तो वो अच्छा खासा टैलेंटेड आदमी को भी सरपास कर सकता है. और मैं कमज़ोर होने के नाते हमेशा जो हार्ड वर्किंग लोग थे उनको पसंद करता था. वे जो बहुत ज़हीन है, छोड़िए उनकी बात, वो क्या करेंगे. जैसे आप देखिए तो मुझे एग्जाम्पल याद आ रही है श्रीनिवास रामानुजन की. हार्डी ने लिखा था, जी.एच. हार्डी की बात कर रहा हूँ, जी.एच. हार्डी ने लिखा था कि अगर मुझे रैंकिंग करनी हो तो आई विल रैंक रामानुजन और आई विल अवार्ड हिम 90, more than 90 marks. I will award myself. G.H. Hardy was awarding himself to 40 marks, and even to great Littlewood 60 marks, and our Ramanujan, great Ramanujan, 90 marks, any marks between 90 and 100. Not because of he was very good mathematician, but he was so brilliant. So it's just because mental power. So whatever is given from the destiny, we cannot change this. Maybe we are in the class of Hardy or even below, but still we can try and do some good mathematics. And at least not, because I remember my teachers here, most of them, my favorite teachers, they were not brilliant. I cannot cut them. Here my colleagues, Dr. Javi, they are Dr. Asif, Dr. Izhar, they all know. They were also their teachers. They are not very brilliant, but they are wonderful teachers and so sincere teachers. So only what we can do our job sincerely. It is not in our control that we can say that I am doing wonderfully certain things, I am great, or so many things. You cannot do that. You can just go and work sincerely. This is what is the. And once one English mathematician told me that you Indians know how to spoil the talent. He framed this very charge And he said in this connection that the world will not be knowing Ramanujan today if you have not made this possible. So Ramanujan is known because of Hardy and because of we people, not because of you Indians, because you know how to destroy talent. So this is all is there, but what is here, we are working for a common job. And जैसा मैंने वो कहा था कि भाई कभी कभी कोई बड़ा पैदा होता है, मगर हम मिल के सब कुछ ना कुछ कर सकते हैं, तो हमें कुछ ना कुछ करने की कोशिश करना चाहिए. बकिया चीज़ें हमारे हाथ में नहीं हैं. हम अपनी क्लास में तैयारी हुई, हमने जावेद से कहा कि भैया ऐसे बोल रहे हो, इसे हम कैसे बोल सकते हैं. सुबह उन्होंने कहा भैया आपको इंगेज करना, कोई टेक्निकल बात में तो और मुश्किल है. जो टेक्निकल बात जो मैथमेटिक्स करता है वो टेक्निकल बात कैसे नहीं कर सकता, उसको करना ही पड़ेगा. तो आप देखेंगे जैसे रिसर्च भी है, यहाँ भी कई चीज़ें ऐसी हैं जो होती हैं. और जब शुरू शुरू में दिखता है, जैसे कल आपने बहुत सारे आइडियाज़ देखे हैं जो बना कंस्ट्रक्शन को प्रूव करते हैं, उसके प्रूफ को छोड़िए, जो उन लोगों ने किया है वो देखिए, तो आइडियाज़ उतने मुश्किल नहीं हैं. एक्सेप्ट कि जो ट्रेजडी वो कल वो बयान कर रहे थे कमची साहब, किसके लिए, फॉर हाँ कैरस्ती. तो समटाइम सच ट्रेजडी हैपेंस, बट ऑब्वियसली दिस इज नॉट ऑफन द केस. So our job is to work sincerely to our respective goal, and we all are one in every sense, you know, because we all work for a common cause. Similarly, teaching is also a common cause. We used to train our youngsters, and it is their duty to take care of what is over here. Because if you come from why I am referring all the time from a background, because your need also compel you to work hard. If you don't have that kind of need, like if you are very prosperous, maybe this very salary is very wretched, you don't want to work hard, what to do, I don't want this of money. This is happening. As sometimes you see many students in a private university, they are not that devoted and involved. So devotion is the main thing. So we should have our devotion. With these words, I thank you for tolerating so many minutes. Thank you. अगर आप में से कोई कुछ कहना चाहे तो मैं सुनना पसंद करूंगा.
कुछ मैथमेटिकल फिजिक्स के बारे में बोले.
देखिए मैथमेटिकल फिजिक्स में मुझे बहुत तजर्बा नहीं, मगर मैं बोल देता हूँ एक लफ्ज़. हाँ चलिए, हाँ ठीक है, मैं बोल देता हूँ. देखिए ऐसा है कि आपने देखा है बगैर मैथमेटिक्स के फिजिक्स पॉसिबल नहीं है. अब मैं अपने पुराने टीचर को याद करता हूँ फिर. This very room has the lectures on axiom of quantum mechanics. I have heard in this very room the axiom of quantum mechanics, and axiom of quantum mechanics cannot be understood, cannot be appreciated without the theory of operators. Those all theory of operators. Like what is operator? And physics people, they were explaining, and we were appreciating it better.